Okay. Now, you were asking about the 10. Actually, please notice here the 120. I hope you understand this 120 where it comes from. Here is 12 g. G is the gravitational constant, which is usually 10 Newton per kilogram. Okay, and this is a Newton. Okay, so it's 120. So this is the weight is actually equals to 120 Newton. So here comes the 120, and this 120 here is the same as here. It's 12 kilogram times g times 10 Newton per kilogram, the gravitational constant. Both are 120. Okay, now this should answer the 10 where it comes from. The same as here, this is the same 120. Now, actually, I was thinking about all that. There is a lot to be said now when we want to understand the static force. But anyway, um, I assume you're fine with this. I hope that. Now, the force we were talking about in part A, here in part A, actually was originally directed this way. In part B, he wants to direct it that way. So this is the force, which is like 82.7. And so there's still the friction force here, okay, the Fs. Now Fs is a static force, but when he asks about the acceleration, now this means that now here's the question for the one who doesn't see it. Anyway, so the friction force should always direct this way. So this is Fr. Now I was originally saying Fs because static force, but when we speak about acceleration, it's no longer Fs, it's actually kinetic friction force. So we can name it Fk or simply F or simply Fr, just to say that Fr I mean friction, okay? And here's the force F, which is this one, 82.7. Now it really, there is not much to link between A and B. I just want to point that because in B he was using the same force we found in A, which is 82.7 directed this way. But really he could have, in part B, he could have just exerted any force and not just 82.7. He could just created a new force and just forgot about the force we found in A, and for example a new force F whose magnitude equals, for example, to 2 Newton. Okay, and the problem still works, and instead of this we can just put 2, okay, 2 Newton, and the same, and all will work fine. Yeah, all should work fine. By the way, I think that these two numbers should cancel each other, huh? I really think so, because shouldn't they, huh? Because I don't know, I feel they should cancel each other, no? Do they? Oh no, uh, no, not no. Oh, I was saying in the first video that the friction force here should be exactly equals to this one, and I was assuming that the friction force, the coefficient is always 0 what, 0.4. Yeah, 0.4. I was assuming that the friction force here is 0.4, so it's 0.4 times r. Okay, now we found r, and we managed to find r. R is actually 120 sine 80. Now they don't seem equal. So this means that the coefficient, in case they weren't equal, these two, so they don't cancel each other, they are not equal. So this means that this coefficient of friction, um, I don't know, they should be equal, unless the coefficient of friction has changed. Let me check if I have the calculator somewhere. It's 120 sine 18. Sine 18. 18 degrees is that? I hope it's, so it's 37? No, I feel not. Let me make sure that it is really sine 180. It should be 0. Yeah, it is. Sine 90. Okay, so it's in degrees. So it was what? 37, huh? 48 cosine 18. It's not. 48 cosine. So no, they're not equal in general. Too bad. I'm a little disappointed. 120, but he said that it was at rest. I'm not too comfortable with that. I'm not too comfortable with that. Uh-huh. But I would be comfortable if what was the answer? It was 45. No, I would be comfortable with that. No, I am comfortable with that. Sorry, I am comfortable with that. And to understand, to be comfortable with that, we need to understand how the static force works. Oh, this is too much to be said here. Now, when we say that the friction force is 48 cosine 18, this is the Fs when it was originally what, at rest. Okay, I'm still here in the assertion at first, the given at first. We didn't have any additional force, only these two forces, this one and this one, on this line. Okay. So please pay good attention. Fs at this moment when it was at rest was equal exactly to this, to 120 sine 18, was equal exactly, and it was not equals to this. Now, and this is how the static friction force work. Yeah, this is how the static friction force works. Because when you apply a minimal force, a force which is smaller than this number actually is the maximum static friction force we have. When you apply a force which is smaller than the maximum that the static friction can be, so the static friction actually minimizes itself to hold the equilibrium. Okay, this is the idea. This is how it works. Now in part A, we wanted to move it this way. So here we had force F, here nothing, and here we had the static friction force, and it was fair enough to move it. Now in part B, it's not like that. It's the static friction should be here because it should oppose to the, because we want to the object to move downwards, and we want to apply a certain force which happens to be 82.7, but really it shouldn't be like 82, but it should not be less than the difference, because sorry, this is a negative number, huh? So this force applied here in part B, it should be like larger than this one for it to move downwards. So this is the whole thing. Actually, now this explains now the whole problem. I hope you're fine with all that. Good luck. If you have any question, you can ask.